This time starting this video, we are looking at probability. So that includes independent events, mutually exclusive events, and then probability distribution. So probability distribution includes discrete and continuous variables. So first of all, we will look at independent events. As two events, A and B, are independent if the fact that A has occurred does not affect the probability of B occurring. So for example, two events that may not be independent would be the probability of selling an ice cream and then the probability of it being sunny, as one of them is linked to the other one, so they are not independent events. But if they are independent, then you would say that the probability of A and B is equal to the probability of A times by the probability of B. Then if it's probability of A or B, that is equal to the probability of A plus the probability of B minus the probability of A and B. And if you remember, in terms of Venn diagrams, the probability of A and B is the middle section in here. So if you're looking at it in terms of Venn diagrams, that is what you're looking for the probability of A and B. But here we have a question, and it says that A and B are associated with a random experiment. Given that the probability of A is equal to 0.5, and then the probability of B is equal to 0.8, and then the probability of A and B is equal to 0.3, show that A and B are not independent of each other. So we're going to be using this idea of probability of A and B is equal to probability of A times by probability of B. So if we do the probability of A, we have 0.5 times by the probability of B, that's 0.8, and that is equal to 0.4. Now we can see that the probability of A and B is equal to 0.3, so as 0.3 is not equal to 0.4, we can conclude that they are not independent. So the next thing to look at is mutually exclusive events. And events are mutually exclusive if they cannot occur together. So this means that the probability of A and B is equal to 0. So if you were to draw a Venn diagram for this, you would simply have two separate circles. That is because you cannot have probability of A and B as mutually exclusive events cannot occur together. That also means that the probability of A or B is simply equal to the probability of A plus the probability of B, as we don't have this middle section to worry about. So here we have a question. It says that three are mutually exclusive and exhaustive. This means that there are no other options, so they will all add up to one probability because there are no other options. And P, Q, and R are associated with a random experiment. The probability of Q is equal to 0.2 and the probability of R is equal to 0.3. So first of all, we need to find the probability of R. And this we will be using this idea that they are exhaustive to show that there are no other options apart from P, Q, and R. So therefore, everything is going to be up to 1. Then we're going to minus the probability of Q, minus the probability of R, and that will give us 0.5. The next one is asking us, what is the probability that it is not P? This notation means not P. So again, we have a probability of P is 0.5, so the probability that it is not P is going to be 1 minus 0.5, which is just equal to 0.5 again. So the probability that is P is 0.5, the probability that it is not P is also 0.5. The next one is asking for the probability P or Q. So this is using the idea of a mutually exclusive event that the probability of A or B is going to be equal to the probability of A plus the probability of B. So in this particular example, what we have is the probability of P is equal to 0.5, as we've worked out. The probability of Q, as it says here, is equal to 0.2. So we're going to do 0.5 plus 0.2. That's equal to 0.7. And then finally, our final question says the probability of P and R. Now this is linking to the idea that they are mutually exclusive. They cannot occur together. That means that the probability of P and R is just 0. So now we need to look at probability distribution. And first of all, we'll look at discrete data, as a probability distribution for a random experiment shows how the total probability of 1 is distributed throughout the possible outcomes. So this particular question here says that a random variable x has a probability function px equals x is equal to 2x minus 1 divided by 36, and then this is distributed between x equals 1, x equals 2, x equals 3, 4, 5 and 6. And this, when we put all of this in, it will all add up to 1 because it shows how the total probability of 1 is distributed throughout these possible outcomes. So first of all, we have to construct a table giving the probability function of x. So that means that we've got a table here, and on the top side, this is going to be x here. And then on the bottom side, we're saying how the probability of x is equal to lowercase x. And that is how you start off one of these tables. And then what we have is you've got 1 here, 2, 3, 4, and 5, and then finally 6. And for each of them, you're saying what the probability is. So probability of 1, for this particular question, all we have to do is substitute 1 in, and that means that we're going to get 1 over 36. And we'll keep everything in terms of 36, even though some we can simplify. Next one is going to be 3 over 36. Again, we're literally just subbing in these. So the next one will be 5 over 36. Then 7 over 36. Then 9 over 36. And finally, we're going to have 11 over 36. So B asks us to find a probability that x is between 1.4 and 3.9. So obviously that's just taking normal values, but what we're going to be looking for is anything between that, and that's going to be 2 and 3. Now as it is discrete data, that means that there's not going to be those in between. So we're not going to be looking for 1.6, for example. So that means that all we're going to have to do is do 3 over 36 plus 5 over 36. That is equal to 8 over 36, which can be simplified to 2/9. So the final question asks us to construct a table for the cumulative distribution fx. So we've got another table here, and for the start we're going to say x again at the top, and then as this is cumulative we've got fx at the bottom. And then we're going to be looking how this is distributed. Now the point of a cumulative distribution is that everything at the end should equal 1, as it is how the total probability of 1 is distributed throughout the outcomes. So we have the same top, it's going to be 1, 2, 3, 4, and then 5 and 6. But this time it will just be adding everything up. So we'll start off, 1 will be the same, 1 over 36. Then it's going to be 4 over 36. Then it shall be 9 over 36. Then 16 over 36. Then 25 over 36. And then finally, by adding that 11 on, we will end up with just 1, which is exactly what we would expect and what we want. So finally, we have continuous distribution, and the probability of a continuous distribution can be shown on a graph. The total area underneath the curve is going to be 1, and that's that idea of it all distributed between 1. And the probability between x is equal to a and x is equal to b is equal to the area between those values. So this is a question. It says that x is a continuous random variable which can take any value between 0 and 1. The probability distribution is shown by the straight line graph. So our first method is to work out what px equals 1. So what's the probability that x is equal to 1? Now, as this is a continuous variable, if we were looking at the area of just x is equal to 1, it's going to be 0. So anything that's equal to, if it was what's the probability that x is equal to 0.5, it would be 0. And that's because the area is going to be 0 if it's just a single point. Then for b, it says that work out the probability that x is between 0 and 1. Well, this is the idea that everything, the total area underneath the curve is equal to 1. So if it's between 0 and 1, total area underneath this is going to be 1. So then the final question says that given b is equal to 3a, calculate a and b. And we know that the whole area underneath this is going to be 1 because the total area underneath the curve is 1. So in order to do this, let's split it up into two things. So what we're going to have is this plus this is going to be 1. So for this one, all we have is 1 times by a. So therefore, that's a. And then for this bit here, we're going to have this is b minus a. And that is 1. And it's a triangle. So that would be plus half b minus a. Now that is all going to be equal to 1. We also know that b is equal to 3a, so therefore we can substitute b for 3a in. So we're going to get a plus half, and that's going to be times by 2a equals 1. So therefore we've got 2a is equal to 1, so a is equal to a half. B is then going to be equal, we know that b is equal to 3a, so therefore b is equal to 3 over 2. So thank you for watching this video and see you soon. Bye.